Hey everyone, Tom here from 40 Plus, and today we're going to be going through the 2022 VCAA Maths Methods Exam 1. Okay, so as always with most exams, the first question is generally always going to be some sort of differentiation. So question 1 asks us to find dy dx when y equals 3x times e to the 2x. So we're dealing with the product rule here, which states that the derivative of u times v is u times dv dx plus v times du dx. So in this scenario, u equals 3x and v equals e to the 2x. So we can say therefore dy dx equals u, which is 3x, times dv dx, which is 2e to the 2x, plus v, which is e to the 2x, times du dx, which is just 3. And then that will give us 6x e to the 2x plus 3e to the 2x. And we can factor this out. So we'll put e to the 2x outside of, 3e to the 2x outside of 2x plus 1. So moving on to part B, they want us to find and simplify the rule of f dashed x, where f of x equals cos x over e to the x. So for this question, we're going to be using the quotient rule, which states that the derivative of u over v is v times du dx minus u times dv dx all over v squared. So let's work this out. In this scenario, u is going to be cos x and v is going to be e to the x. So therefore f dashed x equals v, which is e to the x, times du dx, which is minus sine x, minus u, which is cos x, times dv dx, which is just still e to the x, all over v squared, so that's going to be e to the 2x, and then we're left with minus e to the x sine x, minus cos times e to the x, all over e to the 2x, and then when we simplify this down, we can take e to the x out of both of these, so it's just going to be negative sine x plus cos x all over e to the x. So question 2 is asking us to find the rule for an antiderivative of g of x. It's important to recognize when they ask for an antiderivative, it basically means that you do not actually need to add the constant. They're just asking for a single version of the antiderivative. So you could put plus c, you could put plus 10, you could put plus a million, it doesn't really matter. Or you could just leave it as plus 0 and not have to include a constant at all. So the integral of g of x dx, we're going to simplify it here. We're just going to take the coefficient out. We're going to say is 3 times the integral of 1 over 2x minus 3 dx. So the rule that we're going to be using is this one. So the integral of 1 over ax dx equals 1 over a times log base e of ax. Cool. So we can simplify this down now. It's 3 times 1 over a. A in this scenario is 2, so 1 over 2 times log base e of 2x minus 3. Keep simplifying it down. Simply just 3 over 2 log base e of 2x minus 3. Part B. They're asking us to evaluate the integral from 0 to 1 of f of x outside of 2 times f of x minus 3 dx, where the integral from 0 to 1 of f of x squared dx equals 1/5, and the integral from 0 to 1 of f of x dx equals 1/3. So the way we're going to start this question is simply by expanding what's in this problem. So the integral from 0 to 1 of 2 times f of x squared minus 3 times f of x dx. Now that we've done this, we have it in some familiar terms that we can now substitute, because we already know what the integral of f of x squared is, and we already know what the integral of f of x is, and now it's just a case of dealing with coefficients. So we're going to rewrite this now in separate integral terms. So we're going to say, therefore, equals the integral 2 outside of the integral of 0 to 1 of f of x squared dx minus 3 outside the integral from 0 to 1 of f of x dx. Now, it's pretty much in the form that we want it. So we can simply just substitute now. So it's going to be 2 times 1/5 minus 3 times 1/3. So that's going to equal 2 over 5 minus 1, and that's going to be negative 3 over 5. Okay, question 3. Consider the system of equations kx minus 5y equals 4 plus k and 3x plus y times k plus 8 equals negative 1. Determine the value of k for which the system of equations above has an infinite number of solutions. So we can see that these equations are going to be linear. Well, what does an infinite number of solutions mean? Well, an infinite number of solutions means that they both are the exact same line. Because if we had these two, there's only one solution. Or if we had a parabola, there's two solutions. So for there to be an infinite number of solutions, they need to be the exact same line. Now, there's two criteria that allow this to occur. The first is the gradients are equal. And the second is the y-intercepts are equal. So knowing this, we're going to use these two pieces of information to guide us through this question. The first thing that we need to do for both of these equations is we need to rearrange to make y the subject. So for question 1, it's going to come out as y equals kx minus k minus 4 over 5. And number 2 is going to come out as y equals minus 3x minus 1 over k plus 8. So our first condition is that the gradients need to be equal. And if we can remember, the equation for a linear equation is y equals mx plus c. So the first step is to solve what m would be. Now, in solving for this, we know that the gradient does not involve x. So we're only going to have one variable that we need to solve for. So we're going to say let the gradient of the first one, which is k on 5, equal the gradient of the second one, which is minus 3 over k plus 8. We'll cross multiply. Therefore, k squared plus 8k equals 15. Therefore, k squared plus 8k minus, that was negative 15. So k squared plus 8k plus 15 equals 0. This factorizes to k plus 5 and k plus 3 equals 0. So therefore, k equals negative 5 or k equals negative 3. So we've found two solutions for the gradient. Our next step is to solve for the y-intercept. So we're going to say let minus k minus 4 over 5 equal minus 1 over k plus 8. First step here is to just make things more simple. So we're going to multiply both sides of the equation by -1 to remove those nasty negatives. So therefore, k plus 4 over 5 equals 1 over k plus 8. Similarly again, cross multiply. So therefore, k squared plus 8k plus 4k plus 32 equals 5. Therefore, k squared plus 12k plus 27 equals 0. This is going to factorize to k plus 9 and k plus 3 equals 0. So therefore, k equals minus 9 or k equals minus 3. The last part of this question is to choose the solution which satisfies both conditions. And the only value that satisfies both conditions is k equals negative 3. So we're going to speak to the examiner now. We're going to write a small sentence for them. So we'll say k minus equals negative 3 satisfies both conditions. And hence will produce an infinite number of solutions. Okay, question 4. We're now moving into some probability. So, a card is drawn from a deck of red and blue cards. After verifying the color, the card is replaced in the deck, and this is performed 4 times. Each card has a probability of 1/2 of being red and a probability of 1/2 of being blue. The color of any drawn card is independent of the color of any other drawn card. Let X be a random variable describing the number of blue cards drawn from the deck in any order. Part A, they want us to complete the table below by giving the probability of each outcome. So what we're going to need for this is the binomial equation, which is n choose x times p to the power of x times 1 minus p to the power of n minus x. So in this scenario, n is equal to 4 and p is equal to 1/2. So when we're trying to find for 1, it's going to be 4 choose 1 times 1/2 to the power of x, which is 1, times 1 minus 1/2, which is just 1/2, to the power of n minus x, 4 minus 1, so it's the power of 3. That's going to equal 4 times 1/2 times 1 over 8. That's going to equal 4 over 16, or 1/4. So that's for 1. For x equals 3, it's going to be 4 choose 3, which is exactly equal to 4 choose 1, times 1/2 to the power of 3, times 1/2 to the power of 1. We notice that these two are just the same, so this is also 4 over 16, or 1/4. So now that we've only got 1 left, we know that all probabilities need to add up to 1. So if we add the numerators, so 1 plus 4 plus 6 plus 4, that's going to add up to 15. 16 minus 15 equals 1. So our final probability is going to be 1 over 16. Part B. Given that the first card drawn is blue, find the probability that exactly 2 of the next 3 cards drawn will be red. So this is another case of needing that binomial equation. In the question, they stated that the color of any drawn card is independent of the color of any other drawn card. So this information, that the first card drawn is blue, essentially does not matter to this question, apart from letting us know that n is now equal to 3. The probability of a card being red is 1/2, and we want two of the next 3 cards drawn to be red, so x is going to be equal to 2. So therefore, the probability that x equals 2 is 3 choose 2 times 1/2 to the power of 2 times 1/2 to the power of 1, which is 3 times 1 over 4 times 1/2, and that is equal to 3 over 8. Part C. The deck is changed so that the probability of a card being red is 2/3 and the probability of a card being blue is 1/3. Given that the first card drawn is blue, find the probability that exactly 2 of the next 3 cards drawn will be red. So, this is following the exact same method as Part B, but one thing that's changed is now the probability of a card being red is 2/3. So n is still equal to 3. P is the probability of a card being red is now equal to 2/3. And we still want to find the probability that the next 2 of the 3 cards will be red. So, therefore, the probability of x being equal to 2 is 3 choose 2 times 2 over 3 to the power of 2 times 1 minus 2 over 3, which is just 1 over 3, to the power of n minus x. So 3 minus 2, that's just 1, equals 3 times 4 over 9 times 1 over 3. These two cancel out, so we're just left with 4 over 9. Okay, question 5. So, part A, they're asking us to solve 10 to the power of 3x minus 13 equals 100 for x. So with these exponential questions, we always need to try and identify a similar base or the same base. So we know that 100 is also equal to 10 to the power of 2. So our first step is we're going to write 10 to the 3x minus 13 equals 10 to the power of 2. And we can say, therefore, 3x minus 13 equals 2, because if they're going to be equal, the exponents need to be the same. Then we'll simply just solve this. So therefore 3x equals 15, therefore x equals 5. Part B. They want us to find the maximal domain of f, where f of x equals log base e of x squared minus 2x minus 3. So one thing to always remember with a log function is whatever is inside of the function must be greater than 0. And we can check this by actually converting this log back into an exponent or an exponential, because it would come out to be e to the power of f of x equals x squared minus 2x minus 3. Now, we know that e is a non-zero number, so if we put that to the power of anything, it could never equal 0. So this must always be greater than 0. So that's how we're going to start. X squared minus 2x minus 3 is greater than 0. Now we can factor this quite nicely, so it'll be x minus 3 times x plus 1 is greater than 0. Now, before we make our before we provide the final solution, what I always like to do with these sorts of questions is just draw the graph to actually see what we're looking at. So if we mark our x-intercepts in, we're going to have 1 at 3, which is about there, and 1 at -1, which is about there. We know it's a positive parabola. So it's going to look something like that. Now, we have stated that the graph must be greater than 0. Well, where is it greater than 0? We know that in this area down here, it's not. So the domain is going to include all real numbers except for this section that we've highlighted in here, which is between -1 and 3. So we can say, therefore, x is an element of all real numbers except, and it'll be inclusive of, -1 to 3. Or if you want to keep going the route of using the less than symbols, we can say, therefore, x is less than -1, union x is greater than 3. Question 6. The graph of y equals f of x, where f of x equals 2 sine 2x minus 1 is shown below. Part A. On the axes above, draw the graph of y equals g of x, where g of x is the reflection of f of x in the horizontal axis. So when they give you nice gridded graphs like this, I always find it's nice to just go along the vertical lines they give you to start off with and draw your reference points in there. So we'll have our first reference point there. Second one is going to be there as well, and it looks like every single one of these reference points is going to be along the same line. And then it's always good to go for the maximums and the minimums, like so. And then of course you want to mark in your x-intercepts. They'll just remain the same. And now ready to draw the graph. Looks about right. Let's move on. Okay, so they want us to find all the values of k such that f of k equals 0 and k is an element of 0 to 2 pi inclusive. So if f of k equals 0, that must also mean that 2 sine 2k minus 1 equals 0. So let's solve this. Make the sine function the subject. Sine of 2k, therefore sine of 2k equals positive 1/2. Now we'll come down the bottom and draw out the triangle that we're going to be using. So the triangle we're going to use is the 1, 2, √3 triangle. And we can see the angle that produces an answer of 1/2 when it's paired with the sine function is pi on 6. So that is going to be our base angle. Now we'll draw in our axes with all students take care. So as we can see, sine is only going to be positive in the first and the second quadrants. So we can therefore start to mark in our answers. Now, before we do that, it's always good to, when they give you the graph like this, because you can actually see where the x-intercepts are, so you can see where it's going to be equal to 0. And we can see that there's 1, 2, 3, 4 x-intercepts, which means there's going to be 4 solutions equal to 0, and that means that we only need to actually solve for the first 4 answers. So that makes things a bit easier. So in the first quadrant, we're going to have pi on 6, and then in the second quadrant, we're going to have 5 pi on 6, and then if we add 12 pi to each of, or 12 pi on 6 to each of these, because it's the equivalent of 2 pi, we're going to end up with 13 pi on 6 and 17 pi on 6. Now we simplify this, divide both sides by 2. So now it's going to be pi on 12, 5 pi on 12, 13 pi on 12, and 17 pi on 12. Part C. Let h of x equal 2 sine 2x minus 1, where h of x has the same rule as f of x with a different domain. The graph of y equals h of x is translated a units in the positive horizontal direction and b units in the positive vertical direction, so that it is mapped onto the graph of y equals g of x, where a and b are elements of 0 to infinity, not inclusive. Okay, so what is that basically saying? That's pretty much saying that there's some transformation that has been applied to h of x, which makes it equal to g of x. So let's write out h of x quickly with the transformations applied. So h of x equals 2 sine 2 outside of x minus a minus 1 plus b. And it's being mapped onto g of x, which was the reflection of f of x. So we simply just multiply f of x by negative 1. So g of x equals 1 minus 2 sine 2x. So part 1 wants us to find the value for b. In both of these equations, we know that there is some constant term, negative 1 plus b, and in this case, it's simply 1. And for the equations to be equal, those would need to be the same. So we can equate negative 1 plus b to 1. Therefore, b equals 2. This can also be seen on the graph, where simply the lowest point of the graph of f would have to be moved up 2 units to sit at the same height as the lowest point on the graph of g. So, part 2. They want us to find the smallest possible value for a. So, there's 2 ways to do this, similar to the last question. The first, well, there's one way that we can do it mathematically. That's what we're going to do first, and then I'll show you how we can recognize that on the graph. So we know that for the graphs to be equal, these 2, forms of the sine function must also be equal. So we say, well, therefore, 2 sine, and I'm just going to expand the internal brackets. So 2x minus 2a equals negative 2 sine 2x. Now, if we just draw our normal sine functions quickly, well, we have the positive sine function that looks like that, and the negative sine function that looks like that. And, well, to make the positive sine function look like the negative sine function, we need to translate it negative pi or pi units in the horizontal direction. So there's a translation of plus or minus pi. In this case, because they have said that a and b are positive values, we're going to use a positive translation, or we're going to consider the positive translation and not the negative translation. So we can say, well, therefore, this thing here, well, not inclusive of the negative, just the 2a, 2a needs to be equal to pi. So therefore, a must be equal to pi on 2. So now if we turn our attention to the graph, if we just dot the graph in that has the vertical translation applied, we can see that, well, there's a gap between here that would make these, well, I guess you can say there's the gap between the peaks, and if the graph was shifted by the value of that gap, then it would be equal, it would be along the same line. And well, the grid allows us to see nicely that there is a difference of pi on 2 in that gap. So that's the other way to find that A equals pi on 2. Lastly, they want us to find the domain of h of x. So the way we're going to do that is we're simply going to take the original domain, which was 0 to 2 pi, and then we're going to apply the translation, which was negative pi on 2. So that means that 0 is going to become negative pi on 2, and 2 pi is going to become 3 pi on 2. Question 7. A tile maker wants to make square tiles of size 20 centimeters by 20 centimeters. The front surface of the tiles is to be painted with 2 different colors that meet the following conditions. Condition 1. Each color covers half the front surface of a tile. And condition 2. The tiles can be lined up in a single horizontal row so that the colors form a continuous pattern. An example is shown below. There are 2 types of tiles, type A and type B. For type A, the colors on the tiles are divided using the rule f of x equals 4 sine pi x over 10 plus A, where A is an element of real numbers. The corners of each tile have coordinates 0, 0, 20, 0, 20, 20, and 0, 20 as shown below. Find the area of the front surface of each tile. So the area of the front surface is simply just going to be the area of the square that encapsulates the tile. So that's 20 times 20, area equals 20 times 20, which is 400 centimeters squared. Part 2, find the value of A so that type A meets condition 1. If we have a look at this tile here, we're using the sine function, which oscillates around an equator. So this, for it to be for the color to take up half the area, the equator must sit halfway up the tile. The tile has a height of 20, so that must mean that the equator sits at 10. So say A equals 10. Type B tiles, an example of which is shown below, are divided using the rule g of x equals negative 1 on 100 x cubed plus 3 on 10 x squared minus 2x plus 10. Part B, show that a type B tile meets condition 1. And condition 1 stated that each color has to cover half the front surface of a tile. So we'll say, therefore, area of color equals 200 centimeters squared. And now we just need to check this. So we'll have the integral from 0 to 20 of negative x cubed over 100 plus 3 over 10 x squared minus 2x plus 10 dx. And once we've got that, we get minus x to the 4 over 400 plus the 3's will cancel out, so it'll be x cubed over 10 minus just x squared plus 10x, 0 to 20. All of these, because all the terms in this set involve an x, when we have the 0, we're not going to need to subtract anything. So we can simply start putting 20 into each of these to solve. So what we're going to do with the x to the 4 is we're going to break it into 20 squared times 20 squared over 400 plus x cubed, which is 8,000 over 10 minus x squared, which is 400 plus 10x, 10 times 20, plus 200. Now, 20 squared is 400, so one of these will cancel. So we're just going to have negative 400 plus 8,000 over 10 is 800 minus 400 plus 200. And that equals 200. So we can say, hence, we'll put centimeters squared, hence, type B meets condition 1. Okay, so for part C, they want us to determine the endpoints of f and g of x on each tile, and hence use those values to confirm that type A and type B tiles can be placed in any order to produce a continuous pattern in order to meet condition 2. We'll just write in f of x. So f of x was 4 sine pi x over 10 plus 10, and g of x was negative x cubed over 100 plus 310 x squared, 3x squared on 10 minus 2x plus 10. Yep. Okay. So, well, what we're going to do first is we're going to substitute 0 into both these equations. So f of 0 equals 4 sine of 0 plus 10. Sine of 0 is 0, so that's just going to equal 10. And then g of 0, all of those values are going to be 0 because, well, we'll just write them in. Negative 0 cubed over 100 plus 3 times 0 squared over 10 minus 2 times 0 plus 10. That's just going to equal 10. And then f of 20. So that's going to be 4 sine pi on 10 times 20 is just 2 pi plus 10. Sine of 2 pi equals 0, so that's just going to be equal to 10. Then we'll have g of 20, so that's going to equal negative 20 cubed, which is negative 8,000 over 100 plus 3x squared. X squared, or 20 squared, is 400, so that's going to be 1,200 over 10 minus 2 times 20, so that's 40, and then plus 10. Negative 8,000 over 100 is minus 80. 1,200 over 10 is 120 minus 40 plus 10. And that is going to simplify down to 10. So we can say, therefore, the f endpoints are 0 and 10 and 20 and 10. Therefore, g endpoints are 0 and 10 and 20 and 10. So we say, hence, both type A and B tiles meet condition 2. Question 8. Part of the graph of y equals f of x is shown below. The rule a of k equals k sine k gives the area bounded by the graph of f, the horizontal axis, and the line x equals k. State the value of a of pi on 3. So first we're going to draw out our triangle, which involves pi on 3. So 1, 2, root 3 triangle, pi on 3 is up here. And a of pi on 3 is going to equal pi on 3 times sine of pi on 3. Sine of pi on 3 is going to be root 3 over 2. That's pi on 3 times root 3 over 2. And that is going to equal pi root 3 over 6. Part B. They want us to evaluate f of pi on 3. Now, to find f, we know that the rule a gives us the area. So if we derive a, that means that we will be able to get the function f. So if we say, we're going to say f of x equals d dx, or the derivative of x sine x. Therefore, f of x equals, and we're using the product rule here, so it's x times cos x plus sine x times 1. So therefore, f of pi over 3 equals pi on 3 times cos of pi on 3. Cos of pi on 3 is 1/2. And we know that sine of pi on 3 is root 3 on 2. So that's going to, sorry, I wrote 1/3 instead of 1/2. So that's going to equal pi over 6 plus root 3 over 2. We'll put them over a common denominator. Pi on 6 plus 3 root 3 on 2. And that equals pi plus 3 root 3. Sorry, that's supposed to be on 6. On 6. So finally, we're up to part C, and this is the very last question for the exam. And it says, consider the average value of the function f over the interval x is an element of 0 to k, where k is an element of 0 to 2. Find the value of k that results in the maximum average value. So, well, the average value of the function f is simply going to be 1 over k minus 0 times the antiderivative, or the integral from 0 to k, of sine x plus x cos x dx, and the integral from 0 to k of sine x plus x cos x dx is simply going to give the area between 0 and k. So really, that's just a of k. So what it is, it's 1 over k times a of k. And that's going to equal 1 over k times k sine k, which equals just sine k. And now we need to find the value of k that results in the maximum average value. If we just draw the plain sine graph quickly, we can see that, well, pi is roughly 3.14. So that's greater than 0, which is our limit of 0. So we can say that our limit of 2 is probably about there. So the highest value is going to be this peak, which corresponds to pi on 2. And I mean, we can check this. Sine of pi on 2 equals 1. So that's the maximum value that sine can be. So we'll say, well, sine x peaks at x equals pi on 2 plus or minus 2 k pi. So therefore, k equals pi over 2. And that is the end of 2022 Exam 1. Thanks everyone for watching. If you have any questions, please email us and we'll see you next time.